Hello everyone, this is Direwolf20 and welcome to episode 84 of Direwolf20's Let's Play, where you can see me back in front of my laser display screen here. Want to get working on a couple neat little functions. There's really a couple things I can do with this thing. I've had a few ideas in the back of my head, but not being a terribly good fourth programmer, I'm not sure if I'm entirely there yet and how I'm going to make it work. But there's a couple different things. One of the things I'd like to do is have some kind of game played on this thing. Now, the versatility of this screen is pretty nice in that you can probably have a bunch of different games. I've had a few suggestions in the thread. One of the original things that I was thinking of, and the reason I made it a 10 by 10 screen, is so you could play the game of Battleship on it, where you could have just like a whole blue, thing and just shoot missiles and have red for hit and white for miss and that kind of thing. Now, I have looked into if I can get like random number generators within Forth, so that I could maybe kind of randomly assign positions for ships, but I haven't had much simplistic luck. I mean, there are some out there, don't get me wrong. You can definitely do random number generators, but like it's a little bit above my intelligence level with Forth. But I might work on that. There's another game or two I might want to do. Now, after reading the comments in episode 83, it was clear that some people really enjoyed the Forth tutorial and the amount of programming I did, and then quite a few people also did not enjoy it so much and found it kind of boring and dull. So I think what I'm going to do in this episode, and I'm going to try to do at least, is maybe keep the episode moving at a little bit of a faster pace, but record separately all the programming that I do, and maybe put that at the end of this episode or something along those lines. Or maybe a separate episode, like an addendum to episode 84, where if you want to see all the extra programming, you can go watch it, and if you found that was boring and you're not really interested in it, then you can just watch the main episode, and then, you'll be good. So anyway, why don't I get started doing some of the work on this thing, and then depending on how long it takes me to do what I want to do, I might jump into some other stuff this episode. Otherwise, I'm probably going to be wrapping up at least this display frame this episode. And then, we'll see. Maybe we'll come back another time to work with it some more. But, 85 will probably be something new and different. So without further ado, why don't I get started doing a little bit of the work. And then hopefully those of you who are not interested so much in the Forth programming, I'll be back in a little bit after I've done some of the work so you can see the progress of it. All right, I'll be right back. Alright guys, I need to make a little bit of an addendum to what I just said. I just finished recording the video, and this is me injecting this sequence into the front here. When I started to separate the different segments and try to pull the programming aspects out of the main video, it became very disjointed and hard to follow and hard to understand. So I'm going to go back on what I just said, and you'll hear throughout the video me saying things like this is going to go towards the end in the addendum. I wound up just recording it all in sequence so that it's easier to follow for the people who wanted to learn the Forth. If you didn't want to learn the whole Forth programming stuff and you wanted to skip past a lot of the computer programming, jump ahead to about the 38-minute mark. And like I said, I had to do this because it got really confusing and disjointed and the episode would have turned out pretty badly if I did wind up splitting everything out. So like I said, jump around to the 38-minute mark and you should see the end result of this. And then I'm going to work on a couple other things for you guys at the end of this episode, just so that the entire episode isn't completely about Forth. And then we'll be back in episode 85 to do a lot more cool and different builds, because I'm pretty much done with this light sensor now. Alright guys, this begins one of the extra components. I'm going to teach you guys how variables work in Forth and how to use and define them. Alright, so let's get started with variables. The way you use a variable, okay, first off to define them, you just type in the word variable, all caps, and then the name of the variable. So I'm going to call this variable col1, okay? We'll just do that. Now, col1 is defined as a variable, and if you type the words list there, you'll see col1 is an option. So it is kind of defined as a word, but keep in mind it's actually a variable that'll store some information. Now, if you just type in col1 and put a dot, you would expect that to output the value of the variable, but instead it's outputting this weird thing 9813. What's that? Well, that's the memory address of the variable. If you want to read the data inside the variable, remember you want to use an @ sign. So to do a col1 at dot will give you 0. When we define a new variable, it's defined just 0. Just that's how it starts off. It's empty. It's 0. It's nothing. Okay. If you want to set a new variable to a new number, all you have to do is, for example, if we want to set this guy to 5, we could do 5 to put 5 on the stack, col1, to put the variable on the stack, and then the exclamation point, remember, is what you do to write to a variable. So we're going to write the number 5 to variable col1 and hit enter. Okay. Now if we hit dot again, we should see it's an empty stack. All right, just to make sure that the stack is currently empty. Then we do col1 at dot, and it gives us 5. Okay, col1 at, or col1 dot, for example, again returns the memory address 9813. So the memory address isn't changing. The position of col1 in memory never changes, but basically your the value of it did change. So col1 at, which is say give me the value inside the variable column1, and that'll give you the 5 there. And now we're still at an empty stack. So that's cool. If we want to do 1 plus col1 exclamation, let's see if that works. Nope, I guess it didn't. So maybe col1 plus col1 exclamation, and then col1 at. Oh, I see. I assigned the variable. So what I did here is I tried to take column 1. Okay, I expected it to be 5, but I forgot the at, so it returned the memory address 9814. So now col1 dot is 9813, and then I added 1 to it and stored it in the column1 variable. Well, that was silly. I didn't want to do that. So let's do col1. Let's set it to 5 again. Okay, so now let's try this again. Col1 at, let's give it like a +3. So do 3 plus, and we'll do our exclamation point. Actually, I don't think I wanted to do that. I wanted to put another col1 there. So col1 at dot is still 5. So I want to do col1 at to recall the value. 3 plus col1 exclamation. This I expect to work. Maybe I'm purposely making mistakes so you guys see what not to do. Maybe not. But this should return 8 now, see? So what you want to do is you want to say put column 1 and then use the at sign to get the number 5. So now 5 is on the stack. Then 3 goes on the stack. Then the plus sign combines them, takes them both off the stack, and makes it the number 8. And then we pass the variable name, col1. So right now it has 8 on the stack. We put column 1 there and write to column 1 the number 8. And that's what we just did. Okay, so hopefully you guys followed along, short of my few mistakes there. So basically what we can do here is we can take a variable and continuously increment it. So if I wanted to do just +1, it's real easy. Col1 at 1 plus col1 exclamation. Should make that col1 now equal 9. Perfect. All right. So why would I want to be adding 1 to the column 1? Well, let's take a look at a few things. I'm going to first do the following. So typically I don't want to give things away too much, but if you're watching the addendum here, you already saw what I'm planning to make here. So I'm going to define a new word. I'm going to call it connect4. Okay, and what that's going to do is it's going to set up a whole new game of connect4 for me. But before I do that, I want to create a few more columns. Now I'm going to create a connect4 board, which is basically of size 8 by 7. Okay, so we'll have 8 across and 7 deep. So what I want to do is turn off the row on the front here and the row on the end, and then we'll have like the middle board to work with. And maybe I'll get rid of the bottom 3 so that 1, 2, 3, 4, 5, 6, 7 is available here, and 8, 9, and 10 won't be used. So in order to do that, we'll probably just want to set the white board area. I'm trying to decide how I want this to work. Alright, so what I've done is I've put in the 5th block of my disk here all my variable definitions, column 1, 2, 3, 4, 5, 6, 7, 8. Okay, sounds good. Now let's go to 6 list and see what's over there. Should be an empty block, but I should do a wipe flush anyway just to make sure it truly is all empty and everything. I think if it lists nothing, it's good, but it never hurts to do a wipe flush. Cool. And now I'm going to start programming some of the words that I want to do to play with my whole game here. So let's try this. Alright, I'm actually back at Connect4, and this segment's going to be some more of the special programming behind the scenes footage part of the video. But so basically I've got my 5 list here. I've got variable 1, column 1, 2, 3, 4, 5, 6, 7, 8. Now what I want to do is set up the board and make it look like a Connect 4 board kind of. And what I'm going to do with that is probably the first thing I want to do, and I'm starting at number 8 here, I'm going to do all white, right? So that's what I want to do. So it'll be kind of like that. Okay, so that'll look good. And then I want to do with line 10 here. All right, now remember I'm defining a new word called Connect 4 board. The first thing it's going to do is execute the command all white. The next thing I want it to do, okay, is do a loop, and I'm going to fill in purple on the left column, the right column, and the bottom 3 rows. So the way I'm going to do that is I'm going to start at 1, 1, and then go 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1, 7, 1, 8. I'm going to stop there and go 8, 1, 8, 2, 8, 3, 8, 4, 5, 6, all the way over to 10. And then do 9 all the way over to 10, and then do 10 all the way over to 10. And then I'll probably do the right-hand board, which will be 10, 1 through 10, whatever. And I'll make it all purple, just because I think purple will work. All right, so we'll do 10 pp. So the first thing I do is all white. Next thing I want to do another loop. So remember, you want to set your loop number, the number of times you want to loop, and I'm going to go up to 9. I hope I'm right on this, but I'm pretty sure I am. All right, because we want it to stop at row 8. So I want to say count up to 9 and then stop. Starting with 1, do the following command, okay? And what command do I want to do? Well, I want to set whatever number this is, because we're going 1 through 9 on the row, so all right, so first it'll do 1, and then column 1, and next it'll do 2, 1, so 2, 1, and then 3, 1, 4, 1, 5, 1, 6, 1, 7, 1, all the way up to 8 num. And then the command we want to issue is purple, and then loop, okay? That should be good. Yep, I think that works. Do I1 purple loop. Cool, that should work. 11 row here. All right, now we want to do 11, 1, do. And I could start at 2, but I'm just going to start at 1 to make it simple. And I'm going to do row 8, whatever variable number it is. So it'll start at row 8. It'll do 1, 2, 3, 4 by using the letter I there. I'm going to do purple on that and loop. Okay, 12 pp will be 11, 1, do 9, I, purple, loop. 13 pp will be 11, 1, do 10, I, purple, loop. Okay, so that'll do row 8, row 9, 10. And then finally 14 pp should be, we want to do, let's just say 11, 1, do, it won't hurt to reset the bottom ones, I, 10, purple, loop. And what that'll do is it'll go 1 through 10, it'll do 1, row 1, column 10, row 2, column 10, row 3, column 10. Okay, you know what I should probably do instead of 1, do I, 10, purple, remember caps counts, and then a semicolon to end it. So now, if we do a 5 list, we should see all that cool stuff there, okay? What it'll do is it'll define all the variables, and then it'll define this word called Connect 4 board, which should create my Connect 4 board for me. So let's see what words we've got so far. All right, I'm going to forget column 1. And remember that when you forget a word, it forgets all the words that have been defined after it. So you just look backwards here. So if I do forget col 1 and check the words list, there we go. And I'll do a 5 load, and I'll be back once it's done loading. Actually, let me do a 5 list. Alright guys, so I want to play a game of Connect 4. So what I'm doing is defining some variables, column 1 through 8, and then I'm creating this word Connect 4 board, which will set the whole board to white, like it is now. I'm going to set it all off at the moment. There we go. So it'll make the whole board white, and then it'll make the leftmost column purple, the bottom 3 purple, and the rightmost column purple. And that'll give me a nice 8 by 7, I think. Yeah, 8 by 7 sized board for Connect 4. So I'm going to do a 5 load here. And if you want to see what all my thought processes were on all this behind the scenes stuff on 5 list, just, wait till the end of the video. Like I said, I'm going to be doing that in a bit. So I'm going to let this load up. Hopefully everything works properly. I won't get any errors, and I'll be back. All right, looks like all our words are ready here. The Connect 4 board and columns 1 through 8 are all in position. So now I'm going to do the Connect 4 board command, and hopefully it'll set everything white, and then it'll set purples all the way. Sweet. That's working exactly like I thought it might. Ha! Awesome. And this will be my Connect 4 board. Again, it's going to be 8 by 1, 2, 3, 4, 5, 6, 7. Perfect. So now that I've got the Connect 4 board word ready, let's start playing the game of Connect 4. And this is how I'm going to program it. Alright, this is the segment again for the extra special part of this thing. I'm going to do a 6 list and see where I'm at with this thing. And I should probably flush to disk right now just because I haven't done that yet. But you can see I'm defining a new word in the 6th part of this disk. And let me just do flush, just to make sure everything's written to disk. And what I'm doing basically here is putting the number 7 in each of my column variables. And what this is going to do is it's going to keep track of the position that's already been used. Or I guess the next position to be used when we issue this command. So what we want to do is, you know, put it 7, 7, 7, 7, 7, 7, 7. Okay, that's the position. And what I'm going to do is I'm going to only create a command called drop chip or something like that. And what that'll do is I'll just pass it the column that I want to drop the chip into. And what it'll do is the chip will drop to the position that's available, and then it's going to subtract 1 from that column's available position. And we'll alternate colors like red and yellow or whatever. So hopefully that'll work. I guess we'll find out. So let's do the following. And remember, I'm not super great at 4, so we'll kind of be figuring this out at once. So when we create the game of Connect 4, first we want to set all our variables. Then we want to probably try something different. Hang on one sec. All right, instead of defining my Connect 4 words first, I'll probably want to define another set of words. So instead I'm going to do 0 pp and just overwrite this. Let's call the drop chip command, okay? And what this is going to do is I just want to pass it whatever column I want to drop the chip into. Okay, so colon drop chip and 1 pp. How do I want to drop a chip? Well, I want to take whatever column is currently on the stack, because I'm going to pass it a number first, right? So let's say I put in, you know, column 4, drop chip. Then 4 will be on the stack, and the following commands will execute. So what I want to do is take whatever's on the stack plus whatever's in the column number of this. Oh, yeah, that might be tricky. One sec. Alright guys, I want to be able to pass the variable name in and get both the row and the column of the position here. So if I pass in col2, I want it to output some information that tells it that it's column 2 and that it's currently in position 7, right? Right. And I don't want it to be hard to change around. So how am I going to solve this? Well, I'm going to solve it now, and if you want to see the more detailed explanation, wait till the end of the video. Alright, this is the more detailed explanation of me building the drop chip and Connect 4 game command. So I'm going to go 10 pp, okay? And what I'm going to do here, starting at line 10, is I'm going to define the word for playing Connect 4. So we'll do colon Connect 4. Okay, 11 pp. The first thing I want to do is do the Connect 4 board, so that'll set the board up the way I want it. Cool. The next line I want to do is define all my variables, and I'm going to get rid of this line up here and change it a little bit such that I can store within one variable the individual rows and columns. So what I'm going to do here is I'm going to do 17 col 1 right, 27 col 2 right, 37 col 3 right, and I'll explain why I'm doing this in a minute. Okay, so in block 6 here, I'm defining how I want to create the word drop chip and how I create the new game of Connect 4. So when I type Connect 4, it's basically going to do a new game. It's going to build up the Connect 4 board, and it's going to store in variable column 1 the number 17. Column 2 will be 27. Column 3 will be 37. And basically what I'm putting here is the column number, all right, will be the first digit, and the row number will be the second digit. And you might be wondering why I'm doing that and how I'm going to get the individual row and column out of this. Well, I'm going to use the modular operator, the mod operator, which is kind of like a division where you get the remainder. So let's do an example here. If you think back to division with remainders, what happens if you take 17 and divide by 10? You're going to get 1 with a remainder of 7. And if you think about it, that's the same as saying row 1, column 7. Cool. Cool. So let's try this out, okay? If I do 1710 and do this /mod command, that's basically taking 17 and dividing it by 10. The first number it puts on the stack is the 1, okay? So that's row 1, column 7. Cool. Okay, the second number it puts on the stack is the 7. So there's your column 7. Now that's not what I want to do, so I want to actually swap that. So I'm going to do 1710 /mod swap. Okay, and now what that should give me, okay, if we come up with our next number here, is a dot, which is 7, row 7, okay, column 1. Cool. Alright, so now it occurs to me I want to drop 2 different colored chips. So I'm going to call them, instead of drop chip, I'll call it drop red and drop yellow. And basically this is only going to change a little bit of what happens. Yeah, that should be fine. So I'm going to define a word called drop red. But I'm going to put it in 0 pp drop red. Okay? So there we go. So we're defining a new word called drop red, and we're going to take what we learned with the modular operator here and apply it so that when we drop the red, we can take whatever's in the column 1 position and work with it and get it going so that we can, you know, drop the chip in the right position. So I guess the first thing we want to do is pass column 1. So we'll take that variable called column 1 and we'll put it on the stack. And the first thing I want to do with column 1 is duplicate it. Okay, so we'll do 1 pp. And dupe is the first thing we want to do. So now we have column 1 on the stack twice. Okay. Right now, column 1 is set to value 17. So the next thing I want to do is read that value 17 out of column 1 with the @ symbol. Okay. So now we've taken column 1 off the stack, the top one, and made it 17. So what should be on the stack now? It's 17 col 1, the variable. Okay. Once we've got 17, we're going to do the 10 /mod, and what that should do is take 1710 /mod like I did a moment ago, and that'll give me the answer of 1, or it'll give me 7 1. Okay, now the problem here is that 1 is not actually the column that I want to set. Remember, 1 is this column here. We don't want to be messing with that. We want to be messing with column 2. So whatever I get as the second number there, okay, is the column number. We're going to do a 1 plus to it. And what that'll do is it'll make the stack now be 2 7. Yep, that should be right. Okay. And remember, we want to do the swap command next so that we have it in the position of row column instead of column row. So now what should be on the stack is 7 and then 2. Okay. Hope I'm getting this right. I'm trying to keep track of it all in my head, and it's not easy. And I want this to now set the color to red. And what that should do is go to row 7, column 2, and set that color to red. Okay, perfect. Now the only thing left on the stack at this point is col 1 because we duplicated it early on. Okay, and we want to set col 1 to be 16 now, because the next time we call col 1, we want it to go into position 6 rather than position 7. And this might make more sense once you see it in action. So if I'm not explaining it too well, my apologies. Alright, so in order to do this, first off we want to get the value out of col 1, but we're going to be setting it in a minute here, so we want to duplicate it again. So now the only thing on the stack is col 1 and col 1. They're both on the stack in 2 different positions. I want to read the first one, so now what's on the stack is 17. Do a 1 minus, so it's 16 and col 1 on the stack. Okay, and then I think I want to swap it, right? Let's see. Because right now the stack is 16 on the top and col 1 on the bottom, but we want to swap that so that it's col 1 16, I think. And if I do that, swap exclamation, that should write the new value 16 into col1, I think. Cool. Okay. And then I'm going to do a semicolon, because that should be the end of drop red. And then I'll do 2 pp and do the exact same thing. But for 2 pp, we want to actually define a new word, drop yellow. Okay, so that'll be like the second player, let's say. And we'll do the exact same thing. 3 pp will be dupe at 10 / mod 1 plus swap yellow dupe at 1 minus swap exclamation semicolon. And boy, I hope this all works out. So let's do a 6 list now. Okay, so we're defining drop red and drop yellow, and the word connect for, which should reset the board and the variables. Let's do a flush, and we'll do a 6 load, and we'll see if this works, and I'll be back when it's done. Alright guys, I was super close, but I had one extra swap in there that I didn't really need, and that was the one that was right around here. I didn't need to swap the row and column. So you guys might have noticed that I was making that mistake. It's hard to keep track with stacks, especially because they go in backwards, and if you're not paying attention real close, you might mess it up. So I did not want to swap right here, and that caused a mistake. But I corrected that, I reloaded this list, and now all my words are good. So let's do all off, and that should turn off all the lights on the board. And let's play connect for. You ready? Connect for, enter. And it's ready to go. And what that does, remember, is it sets up the board, and then it sets all the variables and resets them to their new, positions. Okay. So now all the variables should be reset, and we should go pretty well, right? So if we check, col1 at dot should be 17, and col2 at dot should be 27, and col3 at dot should be 37, etc., etc. Now let's say I want to drop a red chip into column 2, for example. So all I gotta do is type col2 drop red. Ta-da! It dropped a red chip. Sweet. Now let's check the value of col2. It should be 26. Perfect. And if I want to drop a yellow chip next, so let's drop a yellow chip into col2. Ta-da! Yellow showed up. Neat. Pretty cool. So let's next do the following. Col3 drop red. Ta-da! And col2 drop yellow. Cool. Col4 drop red. We're playing connect 4. And then what I should do is probably, red's got a situation here that yellow's not going to be able to correct. So let's just do col1 drop yellow. Sweet. And then red's going to win. Col5 drop red. Ta-da! Red wins. And if we want to play again or just reset the board, we just type connect 4. And everything's going to reset on us. Bum, 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 bum. Cool. I'm pretty pleased with that. Alright, now for some more fancy coding stuff. So I've got it set up so I can drop reds and drop yellows, but it's annoying for me to have to keep track of whose turn it is. I'd like the computer to do that for me. So let's get into true falses and some if statements. Okay, so I'm basically going to set up a new variable. And let's just do this on line 7. Alright, so I'm going to do 7 list. Okay. I'm just going to do a wipe flush here, just because I like to do that. Even though it's already empty, and that negates the purpose of wipe. But wipe flush, good. 7's good to go. Alright, so 7 list. Okay, so let's define a new variable called red turn. And we'll let red go first every time. Okay, so 0 pp will be variable red turn. Okay. Nice and easy. Okay, now I want to set red turn to be true. And in fourth, true is equal to -1, and false is equal to 0. And right now, because this is a new variable, we don't want that to happen. So let's do the following. Alright, now before we start actually writing the thing, let's do the following. Let's create this variable, and I'm going to call it red turn. Okay. Now remember, variables start off as 0. Now I'm going to make this kind of work like a Boolean variable, which can either be true or false. And in fourth, true is represented by the number -1, and false is represented by the number 0. So right now, red turn is set to 0, so it's already set to false. If I want to set it to true, I just type in true, red turn, exclamation. Now if I check out what the value of red turn is, remember using the @ command, you can see it's -1. If I want to set it to false, and then do red turn at dot, we should see it's now set to 0. Perfect. Now if we want to just swap it so that whatever it is, we reverse it, we use what's called 0 equals. And the way that works is basically it returns true if n equals 0, or whatever you pass it equals 0. So if red turn is 0, okay, which remember means false, it'll return true, which is -1. If it's anything but 0, it'll return false. Okay, so let's give this a shot. Right now, red turn at dot, it's 0. If I do red turn, and don't forget your at here, it's important, 0 equals, okay, and then say red turn exclamation to write it into red turn, that should work. It should now become true. And if we do red turn okay, like that again, it should now set red turn to 0. Cool. So now we have a way to detect true and false, okay? And what we're going to basically do is store whether or not it's red's turn. If red turn is true, we want to drop a red chip, and if red's turn is false, it means it's yellow's turn, so we want to drop a yellow chip. So let's look into how we do that using an if statement. Now an if statement basically says, and we're going to use actually an if-else statement here, but let's say we want to do the following, and I'm just going to make sure that connect4 is ready to go here. So I'm just resetting the board real quick and all the variables just in case. Okay. Now typically we would do the following commands. We do like call1 drop red. Okay. But instead, I want to check whether it's red turn or not. So let's set red turn to true. Okay, because I always want red to go first. Okay, and what I'm going to do here is define a new word called drop. Yeah, let's call it drop chip. Okay, and what we're going to do is use an if statement. The way we do that is we do the conditional first, which will be red turn. So we're saying if red turn is true. In this case, it currently is true. Okay, then we want to take whatever's currently on the stack, which is column 1, and issue the command drop red. Okay, and then it'll drop red into position. The next thing we want to do is reverse the value of red turn, right? So the stack should be empty after we finish the drop red command, and now we want to reverse the value of red turn, so we want to do the thing we showed you a minute ago. Red turn at 0 equals red turn exclamation. Cool. You know what? I'm not going to do this here. Instead, I'm going to use the else statement first. So then I'm going to do else. Okay? And what this does is says, all right, right now we're saying if red turn is true, then we want to drop red. But otherwise, else, we want to do drop yellow. Okay, and then I'm going to put a then there to let it know that this is the end of the command. Okay, so that's the whole if command. So we're saying if it's red's turn, drop a red chip. Otherwise, drop a yellow chip. Notice that I didn't put the semicolon in yet, and that's on purpose because the next thing I want to do is just swap red turn. It doesn't have to be within the if or else because then I'd have to type it twice. So this is just saving me a little bit of typing in memory. So now I'll do red turn at 0 equals red turn exclamation. There we go. So what this drop chip will do is it'll drop red if it's red turn and then switch it to yellow's turn. If it's yellow's turn, it'll drop a yellow chip and switch it to red's turn. Semicolon. Cool. So now let's give it a shot. All right, so I'm going to do call1 drop chip. It's red. call 1, drop chip. Should drop a yellow, but it didn't. Okay, what did I do wrong here? Let me figure out what I did wrong. Oh, I know what I did wrong. Anybody want to guess? Think about it, think about it, think about it. You ready? Let's fix it. Forget drop chip. Alright, if you want any more time to figure out where my error is, you should pause the video now. Alright, here goes, fixing the error. There we go. That, I think, was the problem. And then we'll do... So remember, I was pulling back the memory address rather than the value of red turn. So I needed to put the at there. Really important. Okay? And then we can do red turn at 0 equals, red turn exclamation, semicolon. Okay? Let's do a red turn at dot just to see. So red turn is currently true. So let's reset the Connect 4 board. There it goes, there it goes, there it goes. And wow, I'm getting hungry. All this programming is making me hungry. Alright, let's try this again. Drop, let's do call 1, drop chip, red. And now let's just check red turn is 0. Aha. Call 1, drop chip is yellow. Call 1, drop chip is red. Call 2, drop chip is yellow. Call 3, drop chip should be red. Beautiful. How cool is that? So we learned all about if statements and else and all that cool stuff. Okay guys, so I've defined a new list here. So let's do 7 list. And what I'm doing is creating a variable called red turn. I'm going to make this thing automatically switch turns for me. Okay, and the way I'm going to do that is first forget red turn and check the words list. Okay, so now everything's back to the way it was just a minute ago. And I'm going to do a 7 load. And what this is going to do is define a new variable called red turn and define a new type of word called drop chip. Cool. And now what I'm doing is I'm modifying the Connect 4 word. Okay, and I'm going to do 14pp. And I'm just going to set red turn to true. And then 15pp, put the semicolon. So now I'm keeping track of whose turn it is, and if you want to see the more detailed explanation, it'll be at the end of this video. But now I'm keeping track of whose turn it is, and I can use the drop chip command, and it'll just drop red and then yellow and then red and then yellow. So we're going to see that in a minute once I finish executing the 6th load. One minor correction to the code here. If you were watching earlier, you saw me put a colon here in front of red turn. Definitely did not intend to do that, so I just removed that. Now I'm doing a new 7 load. Alright, so let's play Connect 4. Just type Connect 4 like that, and it should reset the whole board for you. Dun dun dun. And once it's done resetting the board, we're ready to play Connect 4. Sweet. All we gotta do is choose which column we want to drop a chip into. So let's choose column 3. I'm just going to type call 3, drop chip. And red will go first. And the next person to go will be yellow. So let's do again, call 3, drop chip. Yellow should land on top of red. Perfect. And if I do call 3, drop chip again, it should be red's turn. And then we'll drop a chip into, let's say, call 2. Ah, yellow's going for the angled attack. Not too bad. Red is going to drop a chip into call 5. Beautiful. And we'll let yellow go into call 4 because he wants to drop that, or block that little thing there. Cool. Red might be going for the same thing, the little angled approach, but looks like he wound up helping out with yellow because yellow is going to do a call for drop chip as well. Haha, yellow's working his way up. So that is how the Connect 4 board works. And of course, once we got to the 4th position, we'd be good. So we could do like a call 6, and that'll drop a red chip over there. Okay. Yellow's going to go up that way. Red's going for that, so yellow better block. Much better. Okay, cool. And then red better have to go somewhere, so he's going to try and go for that angled thingy with call 5. Make sure to not use the wrong caps. There we go. And yellow for the win. Hooray! Yellow wins. Now, I didn't program in here anyway for the computer to detect a winning condition. That's going to be up to the player to figure out. But I think it works pretty well, and I'm pretty pleased with the design. Alright, and if you want to reset the game at any point, after a win, loss, or anything of that matter, just type Connect 4 again, and it's just going to reset the board as well as all the variables. Beautiful. And also, you can, of course, at any time type any commands that I had used earlier, and it'll create the little smiley face thing that I made earlier. And then you can, of course, again, start Connect 4 up again, and it'll set the board properly for you. So, we've got a Connect 4 board. And the reason I made this 10 by 10, like I said, is you could play checkers on this with an 8 by 8 board, or you could do chess even if you really want to get complex. So I don't know how to keep track of the different chess pieces. There's not enough colors. You could also play Battleship on a 10 by 10 board. And those are some of the programs that I haven't written yet, and I may at some point, maybe not. I'm not going to make any guarantees about me ever writing those. The one I did today, Connect 4, was complicated enough that made me feel like the other ones might be a little daunting, but probably definitely doable, especially Battleship. That should be a little bit easy. Maybe at some point I'll come back and do that, maybe as an extra episode one day or something. But for now, I'm going to wrap up the segment on the light board here, and it's a very versatile machine. You could really set up anything you want to display different images and play different little simple games. Pretty cool. I'm pretty happy with the way it turned out. Yep, overall, I think this thing turned out pretty well. Alright guys, one little addendum before I switch back to the overworld here, and that's just a minor change in the way the Connect 4 code works. And you can see me typing it at the top up there if you can follow along with it. It's changing all the colors to purple and white right now, and what's going to happen at the end? Heh, nice. So now, let's head back to our overworld and check on some of the things we've been neglecting for the last few episodes. And I do want to create a new age. Dun dun. So the world is going to load around me very slowly, of course, because it's a complicated world and a lot of crazy things going on. I'll probably want to move the age of builds into my Nexus library, but I'll get to that in a little bit. Let's zip around the house here and check on a few things. Yeah, I don't want to make the bee people angry, but all the bees should be processing. I haven't really checked on any of this stuff in a long time, but we're probably getting rid of a lot of junk and a lot of items hopefully coming through and processing. Good, good, good. And all these bee machines are off because I really don't need any of their materials anymore. Cool. So what's the next age that Direwolf is going to create? Good question. Let's get a brand new descriptive book here. I'm just going to take these two, 257 and 258, and combine them and make a brand new age, 281. Sounds good to me. Let's get it in here and set this up. I'm going to call this guy the age of... dun dun dun... alchemy. That's right. A lot of people have asked to see a lot more equivalent exchange, and I feel like, you know what, I've reached a point in the game where resources really aren't a problem, and I can really start going crazy with equivalent exchange. A lot of people have requested to see some of the crazy builds that were made in some of the FTB maps and how to do them, so that's what the Age of Alchemy is going to be all about. It's going to be exploiting equivalent exchange to the max. So let's get this Age of Alchemy ready with some symbols. Do I want to do just a single biome? Let me think. Is there anything in particular I might want in this age besides like a plains or a desert or something simple? I don't think I need any jungle or anything like that. I want it to be a pretty standard terrain, nothing too fancy. Yeah, we don't need any mushroom stuff, I don't think. Though we're going to want a mushroom at some point. We'll be able to get one eventually. That's right, I'll do the mushroom farm for EMC as well. But enough of those spoilers. We'll get to them in a bit. It's going to be a couple things I'll build and show you guys how to build them and how they work and what they do. So for now, let's just go with a simple single biome. And we'll make it a desert biome. That sounds cool. We haven't done much with those yet. We'll do the bright lighting as usual. I think that's probably a good idea. Or do I want standard? Yeah, let's go with bright. no, standard. I changed my mind. Back and forth. We're going to want maybe something cool here. Maybe blue sky, black sky, blue sky. I don't know if you guys know this about the colors that you can do here, and I don't have all of them discovered yet. At some point I might just give myself out of creative mode a notebook so I can make cool stuff. But the colors, when you combine them, will combine this. So this should give me like a little bit of a darker blue sky. But I did black sky and 2 blue sunsets. I don't know why I did that. Oh well. Alright, black sky it is, with some blue sunset. Sure. Yep, let's do the following things here. I'm probably going to want glowstone and crystals might be neat looking. We'll probably definitely want some caves. I don't want huge trees. Lava lakes will be nice, as well as lakes. Don't need any of this other stuff. Ravines. Starfish will probably be good to have. Villages might not hurt either. Terrain generation. Let's make it standard. The time, I know I put some sunset colors in there, but Eternal Day is going to especially help me. I think that'll be useful. As usual, I like Eternal Day, and we'll do no weather again, because we're going to be in the desert anyway, right? So world modifiers we can just leave as we won't do any of those. So the Age of Alchemy. You guys ready to check it out? I think it's ready to go. So let's grab our Philosopher's Stone here, portable crafting table, which I love, and it's definitely one of the things I miss the most on my multiplayer playthrough, server play stuff, having a portable crafting table with me, always having to run back and craft something new. Boy, this Age of stuff, I really have to fix my nether and or get my nexus all set up properly. Maybe I'll do that between this episode and next, but for now, I'm going to just put the Age of Alchemy, dun dun, and go visit it and see how it turns out. But of course, almost forgot, I mean I did create a star fissure, but I almost forgot to get myself a linking book, which would have been a big mistake. Not the like biggest mistake in the world, of course, because I have some in here. And do I have any normal books in here, or just linking books? Just linking books. That's fine. I want to leave those two and get from my white bag here. There's my wrench. Almost forgot. Can you believe it? Good thing I always kind of double check. And since I'm here, I might as well just switch into cheat mode real quick and save 4. And back into recipe mode, just in case, like I said, have one of those little mix-up issues. So book, linking book, good to go. Overworld linking book is ready. To the Age of Alchemy. Let's see what kind of age we get now, and I'll be back once the terrain builds. And oh my, look at this fancy world where I landed. Let's real quick get a link book stand going here. Now I'm definitely going to have to build a house of some sort to house my equivalent exchange, you know, standard stuff. And then we'll get into building some of the more complex things, which will definitely have to be in a future episode. I mean, we're just getting started in the Age of Alchemy. We're going to come back in a future episode here to build the really cool stuff. There's the Star Fissure, by the way. A really nice feature to have. When you jump down in there, it'll tell you back to the overworld. That's a nice thing to use if you do get stuck in an age. And ooh, look, there's a village over here. Sweet. We might even have some tainted areas because we are in a desert after all, and the Vs values are typically very low in a desert. And you can see me getting a little bit of lag because I haven't explored this age yet, and I'm recording. So it takes a while for the terrain to generate around you when you're recording, but that's fine. Lots of glowstone and crystal formations, which is cool. Even got a little bit of a red power volcano here, also nice. So let me get situated in this age real quick, and I'll be right back. Alright guys, I think it would be fun to build my little hut here in the desert out of sand, since there's so much of it around me. But building out of sand is not terribly fun. I'm going to build it out of sandstone. And you can see me looking up the recipes for sandstone there. I know the vanilla recipe, derp. That one's easy. Alright, so let's make a little house out of sandstone here. Now I'm going to grab a few more pieces of sandstone. And just craft them like so. I was looking this up. This is what I was looking to see. If you do this sandstone recipe here, you get this little funny one, the one that looks like a little creeper face. What's up, creeper face sandstone? How's it going? And then you can use them to get like the smoother face sandstone like that. So what I might want to do is get out of my green bag here. What do I always used to build with? The Destruction Catalyst, of course, just to correct mistakes that I build as I build, and the Mercurial Eye. Let's get myself a few pieces of sandstone here using the Mercurial Eye. After all, Age of Alchemy, might as well do things right from the start. Building with alchemy. Wahaha. And the Philosopher's Stone here will help me craft up. And did this thing go into this thing? Probably. Yeah, it did. I'm going to lock him so nothing goes in there, because I'm going to be playing with sand all day. Alright, so I've got this stuff. We'll combine it to make the fancier smooth sand. So now I've got all three types of sandstone here. The one that's all cracked looking, the one that's nice and smooth, and the one that's the little creeper face. How's it going? Sweet. So now I can play around with my Mercurial Eye, and I think I would like most to build with the smoother faced ones. They look kind of neat, don't they? Yeah, they do. Alright, so I should probably build a house. Starting here. 1, 2, 3. 1, 2, 3. Of course, this is going to be a 9x9. You guys knew that, though, right? I hope so. Alright, 1, 2, 3, 4 from the book. 1, 2, 3, 4. Let's just extend this out real quick. 1, 2, 3, 4, 5, 6, 7, 8. Beautiful. Wrong position. There we go. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. Beautiful. So we've got a nice little 9x9 here. I might mess around with making it look a little different with some creeper faces around here and there, but for now, let's just get a roof on it. Cool. I like the way that sandstone looks. Nice. And then, of course, the glass, because we want some light in here. So switch her into transmute mode. Why ain't you transmute? That's interesting. Maybe he can't transmute the sandstone? Ooh, I'm gonna have to let Palmar know about that one. Alright, no biggie. Doesn't have to be in transmute mode. This might even be the faster way to do it. Sweet. Liking it already. And like I said, might throw a few creeper faces around just for good measure. I'm going to clean up the mess I made out here with my Destruction Catalyst. Again, the reason I hang on to this thing when I'm building. To fix the inevitable mistakes. So let's have my door go right here. And we'll just go with the old standard wooden door for now. Shouldn't have too many enemies roaming around on this Eternal Day world. And I wonder if I can transmute from sandstone smooth to creeper-faced sandstone. Nope. Ha, sweet. That's kind of neat, right? Not too shabby. Subtle, but I like it. I guess the bottom of that creeper face sandstone looks the same as regular old, doesn't it? That's cool. I'm down with that. I wonder if I just put one like right here, how that would look. Ha, that's kind of cool. I like it. Nice. Alright, that looks like a nice little hut for my Age of Alchemy. Now remember, I'm going to be doing all kinds of crazy stuff with Equivalent Exchange in this age. You know, trying my best to produce tons and tons of EMC. I'll be making some of the more powerful Equivalent Exchange tools and destroying this world with them. Wahaha. But unfortunately, that's going to have to wait until next episode. But this is the end of episode 84, I'm sorry to say. But I let this episode run a little bit long because I wanted to make sure there was some content for the non-fourth programmer enjoyable guys who didn't like the massive amount of fourth programming in last episode. But this thing has definitely run long, so I'm sorry to say, but it's a pretty good wrapping up point for episode number 84 of Direwolf 20's Let's Play Season 4. Come back next time in 85 to see some of the more crazy and advanced equivalent exchange stuff. Alright guys, take it easy.